So I know you were supposed to have lunch now, but instead you're going to have stats. How awesome is that? Pretty sure this will be your favorite SLU. It will be about stats and pandas. So we'll have two, just to let you know, we'll have two SLUs about statistics. So this one and the next one after lunch. We won't give you a gigantic course on statistics. We'll just really give you the overview, the basic stuff, tell you how to use pandas to achieve those things, and then you have to learn the rest of your own. There will be way more details in the learning notebooks. So here I'll just give you an overview of the concepts, and then during the exercise in the learning notebook, you'll learn the rest, okay? So why statistics? Why are we using statistics in data science? I hope I don't have to answer that question, but just to give you some motivation, you're going to get data sets with thousands, millions, even sometimes billions of data points. How do you make sense of that? How do you summarize the data? And we've talked about outliers a bit in the last SLU, how you deal with outliers. There's this kind of stuff we're going to talk about in the next 15 minutes. So the main objective is to teach you how to use pandas to obtain simple statistics, okay, of data sets. And we'll cover things like how to get the minimum and the maximum, the mode, the mean and the median, standard deviation, what is skewness and kurtosis, what are quantiles, which we also mentioned before, and outliers and how to deal with them, okay? So there's lots of stuff. I'll try to be fast. So let's start with descriptive statistics. So the data set we're going to use is a bit of a silly one, but it's a Legos data set. It's a data set which have sets, and here you'll have the names of the sets, the years where they were released, an ID, and the main thing we're going to look at, the number of parts of each set of Legos, right? And let's start with simple questions. What are the maximum and minimum values for the number of the parts for all the sets that we have in the data set? And which sets do these values correspond to? So simple questions. Let's start with the maximum. So in pandas, you just, if Lego is the data frame you're using, you just call the column you're looking at, in this case, number of parts, and just do .max. That's it. And you get the maximum number. In this case, it's 5,922, okay? But also you may want to know, okay, which set does this number correspond to? And you can use this IDX max to get that. Just be sure you understand that this IDX max function will give you the first index for that maximum value. So if you have more than one set in your data set with this number of parts, you'll get just the first one, okay? But you can also do the same with the minimum. So let's do the other way around. So which is the first set which has the minimum number of parts? This is the one. And which number of parts does this correspond to? -1. Makes sense, right? -1 parts. So you can tell already that minimum, or these basic statistics are already telling you that something is wrong with your data set. And that's one of the reasons why statistics are so important. So this allows you to find some data problems just with this simple thing. So, okay, are there more than one set with -1 parts? Because you really don't want that to be kept in your data set. So you've learned some pandas today. So you can use something like this to just see the part of the data frame that has -1 parts, and if you want, just delete them or try to find out why this is like this. Maybe this was just missing data that you need to fill with something. I don't know. Depends on the use case you're looking at. Okay. So next one, mode. I think you all know what mode is. So for example, what is the year that had more sets published? If you look at the year field in your data frame and just .mode, you use 2014. Okay, so the mode is the most frequent appearing value in a population or sample on your data set. So that's easy, right? Let's go for mean. So for example, what is the average number of parts in the sets of Legos? So you, again, just go for the number of parts, .mean, and you get. So we have, on average, 162 parts in our Lego sets, okay? And if you like math like me, you want some formulas, so you probably know how to compute the mean, right? And if you don't, now you do. Let's go for the median. I hope. Let's go for the median. So the median is like, the idea of the median is that you have your data, you sort it out in ascending order, and you just pick the middle one, okay? And if there happens to be 2 of them, you just take the average of those 2 values, okay? So that's the idea of the median. You have here the formulas, but just check 2 very quick examples. Let's suppose you have 1, 2, 3, 4, 5. The median is 3. If you have 1, 2, 3, 4, the median is 2.5. Right? So why the median? Why are we using the median, not the average? Let's look at a few examples. So let's look at the number of parts on the sets of Legos. The mean we saw it's 162. The median is 45. again, why such a small number? Why is the median and the mean so different? And to understand this better, let's look at another example. Let's suppose we have a data set of student incomes. Like we have a class and we have the incomes of each student. And we check for this data set that the mean income of the students is 600, but the median income is 625, so slightly bigger, okay? But now let's suppose that this kid goes into the class and this kid has an income of 10,000. So just one extra kid in the class. And now the mean jumped from 600 to 903, while the median just jumped from 625 to 630, okay? So what's the consequence of this? Things like this. Journalists doing shitty jobs, saying average student budget up 300. This is a result of our good governance, says this politician. So it's really important to understand the difference between median and mean and why you should use one instead of the other. So a median may be a better indicator of the most typical value if a set of scores has an outlier. So if you have outliers, as we had with the number of parts, well, we have most of our Lego sets have a small number of parts, but there's a few that have large numbers. So the mean will be much bigger, but the median will be reflecting more of like what's more typical value of the number of parts, okay? So, and as I see here, in skewed distributions, the median is not as strongly influenced by the skewed values when compared with the mean. And so here you have a bit of like a summary of what we've been saying so far, okay? Is that fun so far? Okay. So talking about skewed distributions, let's talk about skewness. So here, in the last SLU, you learn how to do some plots. So here we'll have an histogram of the distribution of number of parts of Lego sets. And as we told you before, you see the vast majority of our Lego sets are basically here, right? Have fewer than 1,000 number of parts, which makes sense. But you have here, if you look at the data, some of them will go up to 600, right? We saw the maximum was 5,900 something. So clearly all the data is to the left, right? Almost all of the data is to the left. So it makes perfect sense to call this that the distribution is skewed to the right because mathematicians are fun, right? Or if you prefer, which is what I prefer, this is called a positively skewed distribution. There's also, you can see more in the learning notebook, or if you look at the references, there's a measure of skewness of a distribution, which in Pandas you just use it to, you just have to write .skew to get it. And it's positive when the skewness is positive, and negative when the skewness is negative, and it's larger depending on the level of skewness of your data set. So just to make the point, is on the right is a positive skewness. Skewed distributions on the left is a distribution which is negatively skewed. So skewed to the right, skewed to the left. Okay. Now, standard deviation, also a concept that is quite important. Let's look at a different data set. Here you have the standard distribution into companies, company A and company B. So this is A, B. And if you actually go and compute, for example, the mean of these two standard distributions, you see the mean is basically the same. But clearly, the distribution of the data points is very different, right? For company B is way more spread, and this is reflected in the standard deviation quantity. So you see in the company A is around 50, on company B is around 100. So the standard deviation is computed like this, and in Pandas you just have to do .std, and that's all you need to do to get these quantities. Cool. Okay, kurtosis. What the hell is this thing? And why kurtosis in statistics? So again, I won't go into lots of detail in how you compute kurtosis, but it's just a measure of the amount of tailness that your distribution is. So these are, we usually call these things going with like way less frequent data points, the tails of the distribution, right? Here to the left and to the right. And so what happens is that company A has less kurtosis, company B has more kurtosis. There's a measure of this that you can also find in the references, but it just really a measure of these tailness of the distributions, okay? Further, quantiles, we've mentioned this a bit before in the previous SLU. So quantiles is just how you divide the distribution of the data in certain percentages. So the most typical ones are the quartiles, which divide the data in 45% parts, as we've seen before. So the first one corresponds to all the data in value goes, the first 25% of the data will be here, then the next 25, which then will correspond to the median, then this further 25 all the way to the 100th thing. And here at the middle, we usually call this range between the Q3 and Q1, the interquartile range, okay? And in Pandas, again, what you need to do is just use this .quantile method, and then inside just tell Pandas which ones you want to check. In this case, the 25, the 50 to 75, but it can be other kinds of quantiles. Okay. Fine. Finally, to finish this SLU, let's talk a bit about outliers. So outliers are a very important thing. It's definitely something you're going to see in your career as data scientists. You'll have data sets which have outliers, and you need to really understand why they are there. If they're like data problem, maybe something went wrong with there, or maybe it's just a normal thing, like in the number of parts of Lego sets. It's normal that you have a few that have really large number of parts, but most of the Lego sets will not have that. So especially when you get to the stage where you're starting to use machine learning models, you really need to think clearly on how to deal with these outliers, right? We won't give you all the full recipes now, but we just want you to give a first idea of how to deal with those. The first easy option is to do nothing. In many cases, that might be justifiable, especially if you're using machine learning algorithms that are already robust to outliers, and that's something that you learn during this weekend. You can drop instances with outliers if you realize there are mistakes or data problems and you really don't want them there. Maybe you won't drop a column with lots of outliers. Worst case scenario, you can input values, like you can swap the values of the outliers with something else. None of these first four ways are really recommended, so if possible, don't do any of this. I would suggest one of the last two ones, binning, which is basically divide the data into bins or intervals, such that, for example, the last bin can include all the outliers if there are, for example, all to the right. This is something we'll learn tomorrow, how to do binning efficiently. And the last suggestion is to transform the data. So maybe the distribution as it is like here, it's not really very good to be applied in machine learning models, but you can do a transformation to the data such that all the problem with the outliers is alleviated. And that's the one I'm going to very quickly show you now. The mathematical details of this log transformation are in the learning notebook, so I'll just give you an idea of what you have to do. Let's suppose again that you are looking at the distribution of the number of parts of the Lego sets, so something like this. Clearly, again, this distribution is very skewed to the right. There's probably plenty of outliers, especially over 100 number of parts. So one thing you can do is to pick on this column on your data set, the number of parts, and just apply a logarithm function. And when you do that, you get something like this. So it still has the same information there, but it's just now the distribution here is clearly not as skewed as before. And the standard deviation, the outliers now will all being condensed to this bit. They're not as further to the right as it was before. And again, for certain machine learning models, this will help the performance of machine learning model quite a lot. This is more or less clear. Again, you're going to do this in the exercise notebook, this log transformation, so it's much easier than it looks here. Okay, to recap, actually, so many of the things I told you, you don't actually need to do any coding, you just need to do .describe, and you'll get by free count, mean, standard deviation, mean 25%, 50%, 75%, and max. So you get all of this for free if you just pick one column and do .describe. So that's the tip for you. And now, exercise. And then lunch.